In this video, I want to look at higher powers of I and the pattern that starts to emerge. So first, let's do a quick review of the multiplication rule for exponents. So we know that when we're multiplying exponential expressions that have the same base, we're just going to add their exponents, m plus n, and that base stays the same. That's going to come in really handy here in a moment. So we know that I is the imaginary unit, and it has been defined as the square root of -1. So naturally, following from that, I squared is just -1. All right? Everything that I'm going to discuss for the rest of the video is going to stem from those two facts alone. So the question that we're trying to answer is, what happens when we try to raise the imaginary unit I to higher powers, like 3 or 4 or 50 or 203? Okay? So let's consider for a moment I cubed and I to the 4th. And we'll take some simple samples and we'll see if we can see a pattern if anything starts to emerge. So I cubed can actually be deconstructed using our multiplication property of exponents, and it can be deconstructed as I squared times I to the 1st. And the reason I know this is because the 2 and the 1 add together to get this 3. Similarly, the I to the 4th can be deconstructed as I squared times I squared. And again, for the same reason, because the 2 and the 2 add together to make our 4. So it looks like all of this stuff right here, this I cubed and I to the 4th, has been deconstructed to just I squareds and i's. Okay, well, what does that make then? Well, I squared, we said, was -1, and I is just I. And then here we have I squared times another I squared. So what do these two values actually come out to be? Well, -1 times I is a negative I, and -1 times -1 is a positive 1. Okay, so I'm going to go ahead and start a list over here. I'm going to say I equals I, of course, well, we know that. I squared equals -1. I cubed simplified down to -I. And I to the 4th simplified down to 1. Okay, doesn't really seem like much is going on here. I mean, I have an I and then a 1 and then an I and then a 1, but the signs kind of do this change thing. So I'm not really sure if there's any pattern there yet. So let's continue. Let's say I to the 5th, I to the 6th, I to the 7th, I to the 8th, I to the 9th. And we'll just do a few more terms here and see if we can glean any information about what's happening. So I to the 5th, that could be I to the 4th times I to the 1st. I to the 6th could be I to the 4th times I squared. And again, there's lots of ways you can decompose these. I'm just going to go about it this way. So I to the 7th is I to the 4th and I cubed. I to the 8th is I to the 4th and I to the 4th. And I to the 9th is actually I to the 8th times I. And so let's see what this comes out to be. So I to the 4th is 1. So 1 times I is I. So I to the 4th is 1. I squared is -1. So I to the 6th simplifies down to -1. So I to the 4th is 1. I cubed is -I. So I to the 7th is -I. I to the 4th, well, we have that twice, and they're both just 1, so 1 times 1 is 1. And finally, I to the 8th, which we just did, is 1, times I equals I. Well, now we have a little more evidence here, so let's go ahead and continue my list. So I to the 5th, 6th, 7th, 8th, 9th, and we just simplified all of those, and they came out to be I, -1, -I, 1, I. All right, so let's look at this list. We have 9 different terms here. Let's see if we can, look and find any pattern that might be emerging. So it looks like I, -1, -I, 1, I. Okay, well, here's I again, so that guy came right there. -1, well, we saw him here. negative I, we saw him here, and I, we saw him here. Well, it looks like those first four just repeated again. So I, negative 1, negative I, 1. I, negative 1, negative I, 1. And then it starts with I again. So it looks like these just repeat in patterns of 4. And of course, as it turns out, that's exactly the case. So what happens, I'll draw the line here, let's come down here a little bit. What this means is we can simplify any power of I by decomposing it into some multiple of 4, so 4 and 8, and then multiplying it by the leftover. So why 4? So why is that so good? Well, I to the 4th is 1, I to the 8th is 1, and it turns out that I to any power that's a multiple of 4 is just 1. And we know multiplication by 1 is pretty simple. So what if we have I to the power of 23? So could I decompose that? Well, sure. What's a number just below 23 that's a multiple of 4? Well, 20. And then what's left over is I cubed. So I to the 20th will be 1 times I cubed, which is negative I. So I know that I to the 23rd is negative I. And that's where that falls in my little pattern of I, negative 1, negative I, 1. So I could do this with any power of I. So let's even take I to the power of 102. So I can decompose that into I to the power of 100 times I squared. And again, because 100 plus 2 makes 102. And I used 100 because that's a multiple of 4 that's just under 102. So of course that's positive 1 times negative 1, so negative 1. So what would be an example of where we can use this with numbers? Well, if I have something like 15 I to the 27th, what could I do with this? Well, the 15 functions as a coefficient, so he's kind of there and he's coming along for the ride no matter what's going on. So I to the 27th could be decomposed into, well, what's a multiple of 4 just below 27? Well, 24, and then 3 left over. So it's 15 times 1 times negative I. So 15I to the 27th becomes negative 15I. Okay? And we'll talk about more in further videos, but right there is just an introduction to powers of I and the pattern that starts to emerge and how we can simplify higher powers of I.